Okay, I'm going to talk about the Raspberry Pi Foundation, which is the current adventure. But we'll first of all talk about Cambridge and the ooh, that's a bit loud. We'll talk about the Cambridge cluster. There are about 2,000 spin-out companies in Cambridge, employing about 50,000 people. It's the largest pointer. It's the largest European cluster. It's about 20 billion in value created by Cambridge alumni. Cambridge, let me emphasize, is a small town. It's about 100,000 people and plus about another 100,000 from the university. So roughly 200,000 people. About 20 billion of value, that would be 30 billion euros created by these people. That's not very good compared to Stanford, for example, in Silicon Valley, which is about 1,000 billion. They're about 10 times the size, but we're not 5 times more stupid than there, so there's some structural stuff going on. And we've generated about $7 or $8 billion company billion plus market value capital. You may have heard of ARM, for example. You all have ARM processors in your mobile phones. There are more ARM processors shipped than any other processor. There are more ARM processors than people have ARMs in the world. Verata make network chips. CSR make Wi-Fi chips. Autonomy does business searches, and were just sold to Hewlett-Packard for $7 billion. Cambridge Antibody Systems make drugs. Solexa do DNA sequencing. And we have an active angel group, Cambridge Angels. And the angel group is important not just for the money, but also for the social contacts. We meet once every 6 weeks for a good dinner and exchange the scandal. And we justify it by running some projects. We invest about 12 million a year. And there's a book called The Cambridge Phenomena, which describes the growth of the infrastructure. And the key thing is it's a network. You only invest on the whole with people you trust. And so that limits the size of the network. There's a thing called Dunbar's number, which is the number of friends you have. Not the number of Facebook friends, but the number of real friends you have. And that's limited to about 150. It's the size of a tribe. So your tribe is about 150 people. So that means your network is about 150 squared. People, 1 degree of separation. So you both know somebody in common. That limits it to about 20,000 people. So networks don't work if they go beyond 20,000. They fission into separate networks. So one of the reasons why Cambridge has worked is because it's small. And it's small enough that you basically know everybody with 2 phone calls. You can reach the right person. Or you can check up on somebody by finding somebody you know in common. And that works for employment, that works for investment, that works for technology. And so we have this is a work by Upal Minit and Shivaya Khanam. We have very close networks. This is people who've invested in common or have directorships in common for one particular. This is some software companies, for example, and you can draw similar diagrams for each other major technical, for drugs, for inkjet printing, and so on, for each of the major technologies that we exploit. So networking is key. Having dinner with people is key, because the people you're going to invest in are people you know, or friends of friends. And they go on this. They go on investing. These are over times. And you get key people in the network. Current fantasy is Raspberry Pi. It's a single board computer designed for kids, which we're shipping. Made in the UK. I have one here.
want me to control if someone steals it?
They're $25. It's a full computer, made in the UK, in fact made in Wales in the old Sony factory. It's got everything you want on a computer, storage on an SD card, power from a cell phone charger, TV output, HDMI, so you can use it as a media center, Ethernet, USB LAN, audio, composite video for old-fashioned TVs, and lots of input-output, so you can connect relays and plugs and things like that. Let me explain the genesis of the project. Where did it all start? It started because we can't get enough engineers, we can't get enough programmers. Kids these days don't program, they download. They've lost the skill of programming. And we needed to do something about this. At Cambridge, I'm teaching the computer laboratory, among other things, and I'm on the outreach committee. And we weren't getting enough students to fill the course. We usually teach about 100 students a year. We usually expect 5 applications for every place. It had dropped to 3 applications for every place. So we couldn't get the best and the brightest. We were having to reduce the number of people we took into the course. And that gave us a problem. More to the point, it gave industry a problem in 3 years' time, because if we can't fill the course now, then in 3 years' time they won't have enough engineers graduating. And a number of people realise this. This has been true worldwide. It's true in MIT as well, for example. And we wondered if one of the reasons why this happened like this, if you look at the examination, the number of people taking computing school-level exams has been dropping as well, particularly for girls. The number of girls entering into computer science has dropped dramatically. Last year before last, there were no girls taking exams. We wondered if this was perhaps because they stopped programming at home. In my day, we had things like the Atari or the BBC Micro, whereby you had a computer in your bedroom and you spent time programming. The problem is schools have also changed. They've stopped teaching computer science. They teach something called ICT, which we call typing, how to use office products, which isn't very useful. So we wondered if we made a cheap enough computer that kids could use it, and it didn't matter if they broke it, but they had something they could play with. They would actually go back to programming. Eric Schmidt of Google observed this problem as well, and said the IT curriculum focuses on teaching how to use software but gives no insight into how it's made. So in 2008 I wrote a manifesto saying, what's the home computer for today? What's the equivalent of the BBC Micro for kids? A number of other people came together. Eben Upton, who'd been working for a semiconductor company, Broadcom, had been experimenting with low-cost designs. David Braben writes computer games, and he wasn't getting enough programmers, and he'd been worrying about doing these things. And 2 academics, Professor Alan Mycroft and Rob Mullins, came on board, and we set up a charitable foundation to make a cheap computer and spread the word about how good computing is. We wanted to call it the BBC Micro because that was the original one we all learnt on. And we went down to talk to the BBC, and they couldn't do that anymore because they're now a big corporation. And but they just took a photograph. The technical journalist took a photograph and put it on his blog. Come on, move on. We got 800,000 downloads. This would promise people a $25 computer. This was an early prototype we had that cost several $100s to make. And so we had a problem. We'd promised 800,000 people we were going to make a cheap computer. So we went back and worked quite hard on it. and we were committed. So Cambridge Angels helped with the funding, donations and soft loans. We all put our hands in our pocket. We ran it as an open public project. We got the logo crowdsourced. We got some publicity. Eben's wife manages the publicity and customer relationships. We thought we might sell 10,000 units if we were lucky, because there are lots of other single board computers out there. We purchased the chips for 10,000 units. We found, through a friend of a friend, a contract manufacturer in China. We sent off 2,000 units, 2,000 kits, and hoped. And a couple of months later, 2,000 computers arrived at my garage. And we took one out and it worked. We took another one out and it also worked. So we were quite pleased about that, because we'd never dealt with this guy before. We said we'd launch in fourth quarter 2011. So people interpret that as the 17th of November 2011, because that's the middle of the third quarter. We were beginning to get press saying this is all a fake, it won't work, it doesn't exist. So we sold some early prototypes on eBay. These are $25 computers, remember. They went for $2,000. So we knew we had a problem. We'd also put up the software online. This was for a computer that didn't exist yet and got 60,000 downloads. So we realized this was a bit bigger than me and 6 people part-time in my garage. So we changed model to an IP licensing model. And we, fortunately, 2 distributors, Radio Spares and Premier Farnell, which are multi-billion-dollar companies, came on board. They're big electronic component distributors. They bought our stock and we launched on the 29th of February 2012 and took both their websites down. We were taking 700 orders a second at the peak before the website crashed. We sold 350k the first day, and that led us to certain problems. We had to rapidly learn about volume manufacturing. We'd made 2,000 of these so far. We had to ship, and somehow we had to suddenly get from 2,000 to 350,000. That's a map of where they are over the world. This is, again, crowdsourcing. One of the users put up a map that people could register, and they registered all over the world. We now sell about a third in the States, a third in Europe, and a third in the rest of the world. It's used for kids, teaching kids to program. It's the MIT Scratch language. It's also used as a media center, because we ported the Xbox Media Center to it. We've sold more than 2 million. We're manufacturing at about 12,000 a day at the moment. We have 5 lines in UK, a line in China, and we're starting up a line in South America because of the tariff barriers. But the regulatory hassle, we're no longer a development system. You can't, if we were selling a few thousand, we could slip under the radar and claim we were a development system, so not have to get all the approvals. We now have to be a real company and set up a development, get CER, safety approvals, FCC emission approvals, waste approvals, proper licensing for MPEG and HDMI and all sorts of other things. And because people are using it for lots of control systems and non-educational use, we had to set up a separate trading company. And we're now currently dealing with import tariff barriers, in particular in Brazil. But there's a whole ecosystem growing up of add-on boards for doing things. Minecraft's been ported, plus extensions so that kids can program in it. It's used, very popular in Africa. You can go to a village and drop in a server based on Raspberry Pi that includes the whole of Wikipedia, the whole of Gutenberg literary base, the whole of Khan Academy education base, and health messages and so on. And this is very good. Somebody put it on a weather balloon and took pictures from 40 kilometers up. It's used for process control, in particular brewing beer, camera control. We sell an add-on camera, both a normal and infrared camera. There are all sorts of other uses for it. But the main thing is it's used for teaching kids how to program. The next challenge is to cross the chasm. We're still basically selling to early adopters, to geeks and sons of geeks, or daughters of geeks. So we now need to cross the chasm to make it useful for the mainstream. And that's work we're going on at the moment. It's mainly software work. So the learnings from this is the customers matter, and in general. It's the customers that pay your money. And that's the great advantage of Kickstarter, is you talk to the customers and crowdsourcing. If you can talk to the customers first, you can pre-sell before you have to actually go to the expensive businesses. So for startups, fail early, fail often and fail early. Because each startup is a probe into the marketplace. 9 out of 10 of them will fail, and you want to fail before you spend too much money. But the ones that succeed will succeed big. So talk to the customers before the investors. If I see an investment proposal that hasn't got customer traction, hasn't gone and talked to you, you expect to sell 10,000, go and talk to 100 customers, get their feedback. Do a slideshow to them. If I could build this, would you buy one? How much would you buy it for? Because when you get it out into the market, you'll find things change. They want it green instead of blue. The price point may change. Business model may change. You can't discover that until you go out and actually try talking to customers. And build a community. The thing that's given us strength is the community. The people and that's why we're open source, because we can help build a community. And people will use it if you let them in ways you have no ideas when you started, and will grow the whole project. Okay, that's probably enough. So let me recommend raspberrypi.org. This is the current project. Thank you.